Good morning, good afternoon, good evening, depending on where you are watching me from. In this video, I'll be talking about definite integral. How to integrate definite integrals. We'll look at it together. We'll solve examples. Amen. Before we solve any example, please, I want you to do me a favor. If you have not subscribed to my YouTube channel, try and subscribe. Then go to Facebook, search for Remjog Maths. Amen. Remjog Maths. You will see me there, we'll meet there. If you have any mathematical problem, just snap and send it to this. We discuss. I'm going to make a video, I'll drop it for you to watch. Then go to Google, type this, you will see a lot of mathematical solved problems. Not only mathematical solved problems, you will also see comprehensive mathematics lecture notes there that will help you all through your studies. Thank you and God bless you. Okay, so now let's look at definite integrals. You know, when we say definite integrals, they are integrals of this form. We call these definite integrals. Why? Because we call this one lower limit, then this is called upper limit. Is that clear? Okay. So now, the reason why it is called definite integrals, you know, this integral, you integrate to obtain value. So we call them definite integrals because they have lower and upper limits. Mind you, there is difference between indefinite integral, and definite integral. When we say definite integral, they are of this form. You discover that they do not contain lower and upper limits. We call them indefinite integral because whenever you integrate to obtain a constant. That makes it different from definite and definite integral. Please take note. Don't be confused. Like if you differentiate this function, you are going to have x plus any alphabet, but it must be capital letter. So you discover that we have, if you integrate this function, you have x plus what? Any alphabet constant. K, it could be K, it could be B, it could be C, it could be M, it could be P, but let it be capital letter. So you see the difference. But this one, if you integrate this idiot, you are going to have x limit A running from A to what? B. So it means anywhere you see x, you subtract the upper limit from what? The lower limit. It means anywhere you see x, you write b minus, as I told you. This is the answer. So you integrate definite integrals to obtain what? Value. While indefinite integrals, you integrate to obtain what? A constant. Please take note. Okay, so now let's consider example. Let us quickly look at one example. Okay, so integrate integral 1 to 2 x squared minus 1 dx. It's simple as ABC. Let's write solution. Integral 1 to 2 x squared minus 1 dx. Amen. Okay, so let's look at this idiot. Look at it. We'll do it together. It's not difficult. I'm going to show you. Yes, before I consider this, please, I want us to take note of this. Assuming you are asked to integrate a function of this one, x minus 1 dx. And please, we can solve this, integrate this function in two different ways. You either you do it this way, a to integral a to the x dx. It means you are using the integral to multiply out this bracket minus integral a to b 1 dx. You can also make use of this, but if you want to just do it as it is, no problem. So whichever way, whichever one, you will just arrive at what? The right answer. Okay, so now let's look at it together. This is equals to integral 1 to 2 x squared dx. Then what do we have here? Minus integral, minus integral 1 to 2 1 dx. So let us integrate this function. If we integrate x raised to the power 2, we are going to have x raised to the power of 2 plus 1 all over 2 plus 1, 2 of us. Then integral 1 to 2. Then what do you have here? Minus. You know, 1 dx is the same thing as dx. So if you integrate 1 dx, it's going to give you x. So x integral 1 to what? 2. So this is equals to x raised to the 2 plus 1, 3 all over 3 integral 1 to 2 minus integral 1 to 2. Then we now look at it this way. Let's look at it this way. Okay, I said note that. Okay, so if you can see what I am saying, we now subtract the lower limit from the lower limit from the upper limit. That is, anywhere you see x, you write 2 raised to the power of 3 all over 3 minus 1 raised to the power 3 all over 3. That is what you are going to do. So now here will now be, this is equals to, let's look at it. Okay, we can do it here too. This is equals to 2 raised to the powers of what? 3. We just substitute into all over 3 minus 1 raised to the powers of 3 all over 3. Then what do you have here? Minus x, which is 2 minus 1. Amen. So if you can see what I am saying, look at it very well. If you can see what I am saying, it implies that 2 raised to power 3 means 2 raised to power 3 means 2 times 2 times 2, which is equal to what? 8. That clear? 8. So here will be 8. Okay. 8 all over 3 minus 1 raised to power 3 is the same as 1 all over 3. Then if you can see what I am saying, minus 2 minus 1 is what? 1. Then let's look for the LCM. The LCM here is what? 3, isn't it? 3 to 3, 1 times 8, 8 minus 3 to 3, 1 times 1 all over 3. Then k minus 1. Then this is equals to 8 minus 1 is 7 all over 3 minus 1. Then note that there is an invisible 1. Do you agree with me? So here will now be equals to, this is equals to what? We look for LCM again. So this will equals to 3 will be the LCM. 3 to 3, 1 times 7. 7 minus 3 to 1, 3 times 1 is 3 all over 3. then this is equals to 7 minus 3 is 4 all over 3. So therefore our integral 1 to 2 x squared 1 minus the x is now equals to 4 all over 3. Any question? Just go through it, look at it, go through it. Yes, this is 8, this is 1 all over 3, 1 all over 3, okay, 8 minus 1, 7, okay. So, this is how you are going to solve it. So, see you guys in the next video. Make sure you share it. Thank you and God bless you.